today I want to walk you through the journey of building the data onboarding website, specifically the roadmap and also the wireframe demo. So let's first start with the objective of this website. So right now, the problem we continually seeing is when people ask us where to store our data on Filecoin, and how exactly do it. There is no best place to find those information. So the objective for this website is to really, it's threefold. First, let people know why Filecoin, why it is a better solution than your current, like either centralized storage, public cloud, really showcase the cost benefit comparison of Filecoin. And next is to show the what and how. As a user, we want to help you to identify the right data onboarding tools and really attach a short, sweet video on how. So essentially, very customize the journey based on your needs. And lastly, we want to use this website as an opportunity to build an open community. So anyone, if you want to store data on Filecoin, rather than let the information siloed in Slack, we wanted to have an open forum so people could support each other directly. And essentially, we might even have some data onboarder wizard that can help you in this journey. We'll work with some folks on our team, the client growth team, to develop the planning documentation, essentially source the content and assess the content gap, and really just see what kind of information we could already leverage in the like either Filecoin IO, the main website. The next step for this is to gather preliminary feedback for this website and really work with our customers, clients, some storage providers to get their feedback while we are still developing the mockup. So here is the preliminary website. So this website is still in development and really excited to see how these things will play out next month and eventually get more feedback.
A lot of the work that our teams do on a day-to-day basis involves writing specifications and writing the implementation according to specifications. So these specs, they're really critical, and they only become more important as our ecosystem evolves, as more organizations rely on IPFS and libp2p to build their stack. It's also really important because additional implementations get written in different languages. However, we're kind of in this position where the current specifications don't meet critical needs for a number of different reasons. So, the specifications themselves have inconsistent versioning or lifecycle management. So as a new user or someone who wants to consume the specs, if you're an implementer, it sometimes is unclear how much you can trust a spec. Even though it may be checked into the repo, it's still not, upon reading it, it's still not 100% clear. Specs across organizations like IPFS or libp2p, and even within a single repo, they're not really standardized. So it becomes more unclear in terms of gauging how comprehensive a specification is. And then the specs themselves, right? The content that's within the specs themselves, even though they may be following different formats, those specs are also in like varying states of completion. Those are some of the issues. Like if we hope to, power the Web3 ecosystem with libp2p and IPFS, we also want to make sure that they're well specified so that people can rely on them, have a certain sense of accuracy and trust. Another thing that we're hoping to address is like change management. So we want to have a single place to record and track proposed changes.
The approach we've taken with this has been to kind of take a step back and look at like, what is the ideal way that we want a spec repo to look? We want the specs to look, we want things to be structured, and what is the process we want to evolve things moving forwards?
Really what we're hoping to do is make this not just make the specifications not only consumed by implementers or people who are really in the weeds with libp2p and IPFS, but also approachable to new people. So adding a glossary to the spec, something like that is going to be pretty welcomed by the community.
IPFS nodes, they use the DHT for content routing, which is decentralized but can be slow to propagate the requests. Updates through requires multiple hops to find like a single piece of content on the IPFS, and just generally can be slow. So Filecoin can in the same time benefit from faster lookups by utilizing indexes, which are really fast to find the providers that have a certain piece of content. So recently, as I mentioned on the all hands before, IPFS introduced reframe protocol, which basically allows IPFS nodes to delegate all the routing to some external system. So now IPFS nodes, now basically those who are running the nodes can decide by themselves like how they want to advertise their contents. And what it allows us to do, it allows us to connect to the Kubo node via reframe protocol and capture all the data that this IPFS node has and advertise it out to the indexes. And then through these indexes, people will be able to find this content on the IPFS nodes. So IPFS content can be available alongside the Filecoin content too. We can start trialing the indexing of IPFS on smaller nodes of IPFS cluster that's managed by Protocol Labs. And then like once this is proven to be successful, once we polish the bugs on both the Kubo and indexes side, we can work with the IPFS stewards team on having PL run IPFS cluster to provide index to us meaning to the indexes. And now let me try to show you the demo. So basically, index provider received advertisement from the IPFS node and then advertise it back to the indexes. So now what I can do, I can take the CID of the uploaded file, copy CID, go here and use the indexer command line to find this CID, hopefully. And then it shows that, okay, where this content can be found.
We're getting a lot of feedback from the search providers is that they do not know where is the one-stop shop to get all the resources or information they need to look for, what program we have or the lenders or like vendors or any, like resources available in the market. Because every time we go to meet up in person, but we list out there's new program coming up, they take a photo, but they're not really going back to track, what's going on or how to join them. So that's a kind of pinpoint for search providers and also client side as well. We want to make sure everyone can find everything that ecosystem related in one place. Second of all, we're making sure SPs can start and grow by having one-stop shop place to getting the resource they need. How does it work? We're thinking creating a place involving, all the PMs with their products and also solution builders and vendors. And also make it easy for them can be able to add their program or products or resources by filling out the application in the marketplace. But it's going to be approved and validated by the PL team. And the opportunity, I mentioned earlier, is to create a marketplace. I could say a website as well for SPs getting a resource and program or vendors in the ecosystem. So this is the first version, the software architecture that we have in mind. Basically, it's a place that including program ABC, vendors XYZ, or could be different solutions. But we're gonna direct to the SPs and clients by their size. So I would say really beneficial for both sides. For the ecosystem side, we can literally see who is actually involved in this. Tracking who is the real SP behind the minor IDs. And second of all, we can actually providing clients, matching the right SPs for them to store real data, which is also at the end going to be improving the ecosystem growth.
Backlahau is a network that allows users to submit jobs that gets executed, computation jobs that get executed on a trustless network of nodes. So a job that gets orchestrated, nodes can bid for job execution, some bids gets rejected, accepted, and the end result is made available to the caller using IPFS. Backlog is still under development. It's still a new network with very limited traffic. And what we're missing today is a way to continuously monitor and test the network, test the different APIs that Backlog provides. We would like to have visibility whenever there is any degradation in terms of availability, performance, or anything else that can go wrong. So what I've been working on is a canary that continuously run different test scenarios on the different APIs that we have. And what we have today is a canary that publishes metrics, dashboards, and trigger alarms whenever these metrics reach certain defined thresholds. And also integrated these alarms with the Slack channel that publishes a notification to a dedicated channel subscribed by the operators and the maintainers of the project, or whoever wants to join and interested in knowing the health of the service. Yeah, so the canary is implemented using AWS Lambda. So we have different Lambda functions, and each one of them is running specific test scenario, whether that scenario is testing certain APIs, such as listing a job, submitting a new job, or describing a job, or testing the same API with different different configurations, such as submit with and without concurrency. The Lambda function call Backlog network, submit the job, or call the API, and then publish metrics about that specific execution. These metrics include the latency, the success and failure rate. This allows us to build a dashboard, create alarms, and these alarms eventually integrate with Slack channel. If we go to the next slide and we see the end result is we have on the left-hand side, this is our Canary dashboard that monitors the, we have different graphs for different APIs or different test functions. And on the right-hand side is our Slack channel where we get notified whenever the alarm is triggered, and again, whenever the alarm is back to normal.
We have a faucet for Koi that we've been using for a while, and we wanted to make it a little bit more, number one, user-friendly, to give people sort of an identity after they come out of the faucet. So we wanted to assign a DID so they have something that they can continue using as they work with Koi in the future. We wanted to store that on IPFS and have all the attestations live on IPFS without any on-chain smart contract anywhere. So the whole thing runs on a Koi task, as we call them, which is sort of a bespoke consensus network that you can write in JavaScript. And the data for this kind of DID system that we've created all lives kind of like a DAG on IPFS. And we also wanted to make sure that this was fully decentralized. So while we're using Web3.storage, we've configured that as a default within Koi tasks. So when somebody runs a Koi task node and they select this particular task, they'll be prompted to create an API key for Web3.storage, which hopefully will drive some users their way, but also means that anybody who's writing a task can then kind of use that as a de facto way of storing things. So all of the tasks that people write in the future will hopefully take advantage of the fact that many of our nodes will have these Web3.storage keys. And that should mean that lots of stuff will end up getting uploaded to IPFS. In the future, too, we'd like to open this up to standards so people can use it for a variety of other things related to kind of other Filecoin projects. We'll probably publish the full DID spec as well, so it's nice and easy for people to use. Just to give a quick once over of how the faucet kind of works, there's sort of two main steps here. The first one is people have to get assigned a DID. And the second part is that once they have the DID, they have to get attestations to prove that they have, say, a Twitter account or a phone number or an email connected to it. We have our user, Miley. Let's imagine Miley Cyrus comes through Launchpad and she wants to get approved with a DID. She comes and gets a DID. It's just kind of issuing something and putting it onto IPFS. Once that's up there, then people can start issuing attestations to her, or she can request an attestation. Every time that someone verifies a new form of identity, they'll get more tokens from the faucet. So the first thing that they do, say it's Twitter, will give them their first one token. Once they get that one, the next one will give them double that. And then every time that they add another attestation, they'll have double. We're hoping to add a lot more beyond this, but to start with, Twitter, Discord, email, and phone will be the main ones. Email and phone we're going to be doing from Koi because it's kind of hard to decentralize those at the moment, but gradually we're hoping to add more and more types of verification here that can kind of increase what people are doing. So there's a lot of this is why we set up Koi tasks in the first place, but I think IPFS is going to be a really good area for us to work on this with, and we're going to hope to publish a lot of these as standards so that other people can follow this design process and make good use of the system.
There's been record high interest in opportunities within the PL network. And Ravi and I decided that it might be helpful to create a tool where recruiting team members can click and find candidates through new means or new channels. Ravi and I really focused on the idea that in Web3 and there are a lot of talented individuals who exist outside sort of the traditional hiring avenues. And the question that we posed as working through this was how best can PL access the periphery where a community of these potential candidates reside?
Like, how do we find the best talent for us? And we really wanted to challenge ourselves to think outside, as Dave said, the traditional channel, be it LinkedIn or applicants. There are numerous channels available out there. So we set a target that we are going to at least find 30 channels. As of now, we have completed 9 different channels to find candidates. Now, if you talk about like all these are all separate custom search engine. And we're like, rather than giving somebody like 10 or 15 search engines, why don't we combine the functionality of all search engine into one toolkit? This is just an example how to configure the custom search engines. This is how we did the GitHub parsing. Like, we were able to find candidates. From there, we were able to locate the profile. And from there, on the right-hand side, we got all his social profiles, including email addresses. This is the toolkit we created. It's a website, pretty simple website we created on Google Slide. All the custom search engines are available there. So everything is housed in one place. And as I said, like, we are probably going to add another 20 more resources. So it's publicly available for anybody to use. We kept it really simple in a way that it's not just a recruiting professional can use it. Anybody, even outside of recruiting, should be able to click and find candidates. We talked about OSNIT and image searching. This is how we solve the problem, where we use the algorithm behind the 2 biggest search engines available in the market today right now. And we were able to find totally different set of candidates for one search string. So if you talk about increasing your productivity, like, you can 2x your productivity right away. Like, if you see the results on left and results on right are totally different.